write a pseudocode to move from the start S to the end E in the maze. You can drag and drop the pseudocode magnets to the pseudocode box from here to here and create the appropriate pseudocode, right? So we need to move from here to here. That's a target is given, the task is given to us. So I have 3 pseudocode magnets: for, move, and for. Of course for comes with and for. So I'm going to try this with a simple move. We have a submit. We have a submit button here. I'm going to try this simple move. Let's see what happens. The cursor is here right now. I click on yes, submit. It moved 1 box. I'm going to try with 2 more. Let's see what happens. So it moves 2. So I'm going to repeat the task again and again. 1, 2, 3, 4, 5. So I should have 5 moves. Instead, what I'm going to do is I'm going to have 1 for loop, then 1 move, and end for. So for starts to 0 to counter 0 less than or equal to 4. So it will iterate for 5 times. So I'm going to click on it. Okay, I'll have to come down, then move also has down part. So 1, 2, 3, 4, 5, 6, 7. So what I'm going to do is I'm going to use a for loop, just to drop and drag, right, and then for. So instead I'm going to use move down 0 to 6. It must work now. Comes here, yes, it stops right here. Then I'll have to move right 1, 2, 3, 4, 5, 6 E. So it has to come here, so it's 6. So instead of counter value 0, I'm going to use this time counter value 1. So what I can do is I'm going to use a counter value 1. So there are 6. So less than or equal to 6. Move right. I think that's it. Yes, it says you have reached the destination. Your answer also has been submitted successfully. Now let's move on to the next problem statement. Write a pseudocode to recreate the figure given in the expected canvas for the scenario. So this is the expected canvas, this is the current canvas. What we see here is we see a snowfall, we see a sun, and we also see 4 sheeps, right? Then we see a mountain. Then I'm going to say display mountain, drag and drop it here, display daylight. So it's not display moon. Yeah, display sunrise. Yes. Then yeah, we are going to only 1 mountain, so I'm going to add a mountain. There are no trees, right? Then there are sheets, but sheets are 4. So I have only 1 magnet, so I'm going to use a for loop. 0 less than or equal to 3. That's a condition. I'm going to add a sheep. Then end for. Right, let's see what happens. Your answer is wrong. Why? Because snowfall is missing. Everything is same. Snowfall is missing. So we're going to add snow somewhere in the pseudocode magnets. Let's see what happens. Your answer is right. Your answer has been submitted successfully. Then let's move on. Write a pseudocode to recreate the figure given in the expected canvas for the scenario. So this is the experiment. So we see rainfall, moon, 3 mountains, 1 tree, and 2 sheeps. Right? So we have 2 loops. So I'm going to use them to add 3 mountains first. So 0 less than or equal to 2. So when the condition is 0, it is true. When the counter value is 1, it is true. Condition is true. When the counter value is 2, the condition is true. When the counter value becomes 3, the condition fails. So it comes out of the loop. So it is going to add 3 mountains. So 3 times we are going to iterate. Let's have end for has to come with the end. Then we have 2 sheeps. Let me take one more loop here. Let me have an end for. Then sheeps, right? Add sheep. Fix it in between for and end for less than or equal to 1. So it will add 2 sheeps. Then there is a rainfall. There is a rainfall. So you can add display rain. Yes, it is a night sky. Display night sky. And then display moon. So if you're done with this display moon, display rain, display night sky, then use a for loop to add 3 mountains, use another for loop to add 2 sheeps. Then let's submit. It says your answer is wrong. Something must, yes, we missed out a tree. Since the tree is only one, we don't need to have a loop. We can directly add. So let's click on submit. Yes, your answer is right. Your answer has been submitted. Let's look at the last exercise of this chapter. So write a pseudocode to calculate the factorial of a given number. So we know what is a factorial. If they want us to find out factorial for 5, it is 5 into 4 into 3 into 2 into 1. It's 120. If it is going to be 4, it is then 4 into 3 into 2 into 1. And we can do it in the reverse order also. 1 into 2 into 3 into 4. That is also fine. So basically what we're going to do is, according to the logic, if you're going to take the number value, right, simply if it is a 4, then reduce it by 1, so it will become 3, so 4 into 3, then reduce 3 by 1, it becomes 2, 4 into 3 into 2. That is the way we need to proceed, right? So first and foremost step should be input number, right? And if you look at this pseudocode magnets they have used if and else. So it is important that we also use if else within this place. So if the number equal to 0, then the value of factorial should be 1. So 0 factorial value is 1. Else, so else the rest of the process comes in picture. So if not, what I have to do is I'll have to factorial is equal to 1, else part comes with factorial is equal to 1. Then what you have to do, while number not equal to 0, you will have to do factorial is equal to factorial into number. Then what you have to, you'll also have to number is equal to number minus 1. Then finally you will have to end while, end if, then display factorial. So it checks if the number equal to 0, then factorial value becomes 1, else it finds the factorial value. If it is say 4, then it comes here 4 not equal to 0, condition is true, factorial is equal to factorial into number 1 into 4. So now the factorial will have 4, right? I can actually demonstrate here, which would help you to understand things better, right? So let's say if the number is equal to, right, if say assume number is equal to 4, then what will happen? It comes here. So I take number as a number as a num, n not equal to 0, condition is true, and what happens? Factorial, you already have assigned initialized factorial to 1. Here you have initialized factorial to 1. Then you say factorial is equal to fact into number n. So what will happen this time? 4 into 1. This is what will happen. This is a first iteration. So it comes down, n is equal to n minus 1. That is what you have given. So number is equal to number minus 1. What will happen? Alright, n is equal to n minus 1. So it will be like 4 minus 1. So it will be 3. N will become 3. This is the first iteration. And when it comes to second iteration, this is iteration number 1. This is iteration number 1 over. When it comes to second iteration, right? Second iteration. This is the above one is a first iteration. Above one is the first iteration, and this is second iteration. So second iteration, what will happen? You will check n not equal to 0. Number I have taken as a n. For a short form, I have taken as a number is a n. Factorial as a fact. Yes. So the condition, which means now the value of n is 3. Value of n is 3. So you say n 3 not equal to 0. The condition is true. Then what will happen? Fact is equal to, fact already is holding the value of 4 into 1, 4, right? So fact is equal to fact 4 into number, that is what you have given. So what will happen? You will add 3. So this time the value will become 12, right? Then what will happen? Value of n will get reduced, so n of value will become 3 minus 1, that is equal to 2, right? So I want you to try this for the rest of the. So once it is over, factorial will have a value, then finally you will have to end the while is part of the else part, so you'll have to end the while, then you will have to end the if, then finally display the factorial. Let's submit and see what happens. Yes, the answer is right.